Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have 16th lecture and the topic is plate type evaporators, starting, stopping and care of evaporators. In this tutorial, we will first learn about the layout of plate type evaporator and the flow of fluids through it. Then we will discuss the starting procedure of freshwater generator. Next, we will learn about the stopping procedure. Then we will learn about the care required by freshwater generator. Next, we will learn about the causes and remedies of scale formation in evaporator. Lastly, we will learn about the restrictions on use of freshwater generator. Let's discuss these through the following slides. Layout of plate type freshwater generator. The sketch shows a plate type freshwater generator which provides a compact arrangement with ease of maintenance in comparison to shell and tube type evaporators. Although this type of freshwater generator is costly due to use of titanium plates and stainless steel housing, it is gaining popularity over the shell and tube type evaporators. The freshwater generator shell is divided in two sections, separated by a division plate. Plate type evaporator is housed in the lower section and the plates carrying the seawater have opening on their top for discharge of water vapor and brine. The plate type condenser is located in the upper section and the plates collecting the condensate have their opening on the top for the entry of water vapor. Freshwater generator shell is sealed by a hinged cover which holds knitted monal wire demister in line with the division plate and prevents the entry of seawater droplets along with water vapor. Ejector pump supplies seawater to the freshwater generator which is discharged overboard. Air and brine ejectors draw air and brine respectively from the top and bottom of the shell and maintain the vacuum. When 90% vacuum is attained, seawater feed is supplied to the evaporator through the orifice. Engine jacket cooling water is circulated through the evaporator plates, which boils part of the seawater and the remaining is discharged as brine. The evaporated vapors pass through the demister and get condensed in the condenser shell. When condensate level is visible in the side glass, distillate pump is started and condensate level is manually controlled. The salinometer constantly monitors the salinity of distillate As long as the salinity is more than 10 ppm, solenoid valve returns the distillate to the shell, which is discharged with brine. When the salinity drops below 10 ppm, distillate is discharged to freshwater tanks. Starting procedure of freshwater generator. We will learn step-by-step procedure of starting freshwater generator. Condition before starting. Freshwater generator is usually started when the ship has come out of the port limits and the engine speed has been increased. Closing the vents and drains. Close the vacuum breaker and evaporator drain. Creating vacuum in the shell. Set the seawater line and start ejector pump. Release the air from water boxes in the condenser. Open seawater feed. When the shell has attained 90% vacuum, open seawater feed to the evaporator and regulate the supply. Start heating the seawater by jacket cooling water. Start the circulation of jacket cooling water in the evaporator and regulate the supply through the bypass valve. Vent the air from the evaporator shell. Start distillate pump. When the condensate level is visible in the condenser shell, set the distillate line for the freshwater tank. Start the distillate pump and maintain the water level in the condenser shell. Switch on salinometer. Switch on salinometer and observe the salinity. Note flow meter reading. Note the initial reading of the flow meter for recording the output. Start chemical dosing pump. When freshwater generator operates normally, start chemical dosing pump. Record the parameters regularly. Record the freshwater generator parameters regularly to closely monitor its performance. Stopping procedure of freshwater generator. At the end of the voyage, before arrival in the port, main engine speed is reduced to pick up the pilot. While reducing the speed, freshwater generator is stopped because enough heat is not available and the seawater is also infected by pathogens near the ports. Stop jacket cooling water. Open jacket cooling water bypass valve and close inlet and outlet valves before the evaporator. Stop distillate pump. When the condensate level in condenser drops, stop distillate pump and close flow meter outlet valve and record the reading. Stop chemical dosing pump. Stop chemical dosing pump and close its delivery valve. Switch off salinometer. Switch off the power for salinometer. Stop seawater feed. When evaporator cools down, stop feed water supply. Stop ejector pump. Stop the ejector pump and secure all seawater valves. Open vacuum breaker. Open the vacuum breaker valve to admit air in the shell. Open evaporator drain. When shell is at atmospheric pressure, remove the seawater from evaporator by opening its drain. Care of freshwater generator. For optimum performance of freshwater generator, regular care is necessary during operation and after its stoppage. Care during operation. During the operation of freshwater generator, following care is essential. Operating under high vacuum. Freshwater generator should be operated when vacuum in the shell is more than 90%. If there is a drop in vacuum, reason for low vacuum should be established and rectified. Maintaining optimum shell temperature. Freshwater generator should be operated with shell temperature between 35 to 40 degree centigrade, as the risk of scale formation in evaporator tubes is minimum in this range. Shell temperature can be maintained by regulating the quantity of jacket cooling water using the bypass valve. Ensuring adequate feedwater supply. Feedwater supply should be between 3 to 4 times of the desired output, which is essential to remove the salts left by the evaporated water, and the brine level should not rise. Ensure chemical treatment during operation. Ensure that chemical dosing is maintained during the operation of freshwater generator, as it prevents scale formation. Ensure correct operation of condenser. Condenser should be supplied with normal seawater temperature, and the temperature difference across inlet and outlet should be about 6 degrees centigrade for best performance. When seawater temperature is above 30 degrees centigrade, freshwater generator should be operated at reduced capacity. Care after stopping. When the freshwater generator has been stopped after the voyage, following care is necessary. Chemical cleaning of evaporator tubes. Evaporator tubes should be chemically cleaned to remove the scale deposited, followed by neutralizing the same. Maintenance of condenser. When the performance of condenser drops, tubes should be cleaned and zinc anodes in the water boxes should be renewed if found used up. Pressure testing of the shell. Freshwater generator should be pressure tested when necessary to check for any leaks in the system. Causes and remedies of scale formation. Causes of scale formation. Scale may deposit in the evaporator tubes due to the following reasons: high shell or evaporation temperature. Operation of freshwater generator with its shell temperature above 45 degrees centigrade can cause scale formation on the evaporator surface, which may be due to lack of vacuum, high seawater temperature, insufficient flow of seawater in condenser, or a dirty condenser. Insufficient supply of seawater feed. Insufficient supply of seawater feed results in higher density of brine, which is responsible for scale formation. Feed water supply should be between 3 to 4 times of the desired output. Salts responsible for scale formation. Seawater contains approximately 32,000 ppm of dissolved salts consisting of sodium chloride, magnesium chloride, magnesium sulfate, calcium sulfate, and calcium bicarbonate. Following salts are responsible for scale formation. Magnesium hydroxide. Magnesium hydroxide is broken down from magnesium chloride, which has low solubility in water, thus it can deposit and form scale. Magnesium sulfate. Magnesium sulfate is soluble in water under low concentration, but when its density increases, it can come out of the solution and deposit scale. Calcium sulfate. Solubility of calcium sulfate decreases with increase in temperature and it forms very hard scale. Calcium carbonate. Calcium carbonate has low solubility which also decreases with increase in temperature, but it forms soft and porous scale which is not very poor conductor of heat. Remedy to prevent or remove scale formation. To prevent or remove scale formation in evaporator surface, following treatments are carried out. In-service treatment. Scale inhibitors used during the service interfere with the crystallization process of these salts with scale forming salts. Some chemicals bind the scale forming ions in the solution and prevent their deposition. Scale dispersants used disperse the small particles and prevent their deposition. Using descaling agents. When the freshwater generator is stopped, evaporator surface is descaled by using acid followed by the neutralization. Limitation on use of freshwater generator. Freshwater generator has certain restrictions for its use due to the following reasons. Main reason for limitation. Freshwater generator should not be operated within 20 nautical miles of the land or estuary, as the seawater may be heavily infected with bacteria which may get transferred to the produced freshwater. Additional reason. Seawater near the coastline may be polluted by sewage, disposal of chemical waste from industry, drainage of fertilizers from the land, and in some cases by spillage of cargo from ships. Standard practice of operation. Thus, it is the standard practice to start freshwater generator when ship proceeds to sea after disembarking the pilot and is stopped at the end of the voyage before picking up the pilot. Use for special requirement. However, in case there is need to generate distilled water for boiler, freshwater generator may be operated in port if it is equipped with steam injection arrangement. This completes the study of this lecture. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on ships, auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notifications about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.